Okay, keep this theory in mind. Why? Sorry, somebody had a point. Go ahead. No?
Yeah, just a quick question. How do we get this ad stock / retention rate? Is that
Okay,
something?
So this
walk
comes
through
from
the- yeah.
yeah.
So, Mari, why don't you do the walkthrough right now? Go open up your code and walk through the Robyn code, and maybe you can point out how to get the ad stock out of the R code that you have written up for it.
Sure. How much time do I have?
You've got about let's call it 10 minutes, maybe 20 minutes most.
Yeah, sure. Okay. So I think so let's understand how to use Robyn for MMM models. So the installation is pretty simple. We just need to say install.packages Robyn. It's going to install it. And even the dependent packages it is going to install it is very straightforward. So as a first step, we will load the data. So the data that the results that we were looking at. So I think Payman also mentioned about this. The quality of the data is very important before feeding it to the data. So we should typically try to understand the at least plot these let's say these sales and different marketing activities, at least plotting a line graph where you have week on your x-axis and then sales on your y-axis to understand if there are any missingness in the data, which is very important. And also if there are, if we understand that those missingness could be due to the a problem in the system, let's say that there are some weeks for which the sales values are missing, we could use some kind of an imputation method. But if we see like abnormal spikes and dips in the data, it is important to understand what really happened during that time, and then using those information in the model as factor variables. And also in the marketing or these media data, we could have some anomalies. So it is important to understand why those are happening, so to make sure that we are using the clean data. So in this data, we have the time dimension, which is week here. So it could be day as well. And this is our dependent variable, new customer sales, which is a total revenue coming from the new customers. And we have the set of, especially the marketing, the media as well as non-media variables. So in the media, we could have both paid and organic media. And in the non-media, anything that we think would be useful could be added. So, but seasonality, trend, and holidays could be automatically added by Profit. So I'll come to that. Robyn also gives us a holidays file, so which has the holiday information across 59 countries, the national holidays. But if we think that the certain events, like for example, Black Friday, if we feel that that is going to have an impact on my sales, that could be added to this data frame. We could append those dates as well. Next, let's go to how to specify these inputs to the Robyn. So we have this function called Robyn inputs. The first argument is the data frame that we just looked at. We need to specify that. And then the holidays data frame. What is our time dimension? In our case, it is week. And what is the dependent variable? New customer sales, and its type, whether it is a revenue or a number of conversions. So this is going to be used depending on its type. It is going to calculate the ROI or CPA for us, or ROAS or CPA for us. And the profit this is about using trends, seasonality, and holidays in the model. So we can specify these strings accordingly. And the country for this data was US. And then this is important parameter, paid media spends. These are the mandatory set of paid media that we want to understand the contribution for. And in this case, we have Facebook spend, Snap spend, and then Google search spend. And this field, paid media is the corresponding the exposure variables. For instance, for Facebook, we are using Facebook impressions, Snap impressions, and then Google clicks. go for
Hey,
search, please.
Mari, just 1 second. Shubham has a question. Go ahead, Shubham.
Sure.
Yeah, sorry, just here, like how important it is to specify the directions of these, let's say even the profit variables and contextual variables here. Like, do we need to tell the model that season would have a positive impact on my sales or like that?
No, yes, I mean, the Profit has a capability to specify the sign as well, but it is generally not recommended to specify the sign for these variables, right? So seasonality for some periods let's say in a year, let's say first quarter, it can have a positive impact, and then in the fourth quarter, it can have a negative impact. So we shouldn't really enforce that unless we know that, for example, these paid media VARs would have at least a positive or non-zero, non-negative impact.
And how about contextual variables?
Yes. So the context variable, I missed it. Sorry. So the context variables are nothing but any kind of non-media variables, right? So let's say completer spend, price and promo, or unemployment rate, and any kind of non-media variables could be added. And even here, let's say, for example, completer spend, if we think that is going to have a negative impact on our sales, so we could specify the sign of that. So in this example, I don't have that, but Shubham, I will send you the parameter that needs to be used to enable that.
Okay, so when you say discount, so it would be like the discount percentage which is going on, or how we will like append the promotions or discount as contextual
Yes.
variable?
Yeah, the price reduction or even the discount percent could be used as one of the predictor variables. Or let's say you have some kind of in-store merchandising, right? So you have some kind of promotional activities happen. So we can add a factor variable saying during these weeks there was some promotional activity, and then rest of the weeks we didn't have anything. It is going to automatically encode it to 0 or 1 and use it in the model. So that would be part of the factor variables. So we have an argument called factor VARs. So that is going to be the subset of context VARs, right? All those factor variables, the categorical variables in the context VARs would be part of that. I will send you the argument for that as well. I thought that would be too much for this class, so I didn't include that.
Okay, and in paid media variables, you are saying that it is mandatory, but if it is not available, like impressions and clicks, then what we can do about that?
So yeah, so you should at least have a spend. If you do not have impressions, at least you can use a spend as a predictor variable, right? So typically we would observe a pretty high correlation between spend and impressions, but some cases like GRPs, we don't typically see that. But if you do not have impressions, you can use a spend as a predictor variable.
Yeah, so that's what like generally they would have very high correlationality. So should we have them? It is recommended to have them or not?
Oh, it is not going to use both of them at the same time, right? So in this case, so this paid media VARs, it is used to calculate the ROAS, right? It is not going to be part of the model. But if you do not have any exposure variable, only have spend, you can use it as the inputs to the model. Essentially, everything in this list, paid media VARs, would be used as the independent variables or predictor variables in the model. This is used only for the reporting purposes. Okay. And the organic variable, this is any kind of media which does not have a spend associated with it, like even the blog posts or even organic social media data like organic LinkedIn and Facebook, or any kind of owned media could be part of this organic variables. So the window start and end, model begin and end date, which we would recommend at least for 2 years, but sometimes you would see that the 2 years back the business was so different that it is not even representative of the current business. So in such cases we could go for a shorter window, but it's recommended to use 2 years at least to get a proper estimates for trend, seasonality, and especially trend and seasonality, because seasonality requires at least 2 years of data, and trend also we don't want to pick the short-term trend. So the ad stock, this is what we looked at, a geometric ad stock, which has the constant decay rate. We looked at the half-life and the retention rate. So we should also look at the saturation, the diminishing returns nature of media. As Madan was explaining in the previous lecture, so every additional unit of advertising is not gonna produce a response in the same rate. So we probably have reached our target audience at least at an effective reach. I mean, only the potential percentage of target population we are able to reach, and probably we have reached them enough number of times that any kind of additional advertising is not having any impact, so not having the same impact. So we need to account for this in the model. So let me show you some plots around the saturation. Before that, so we need to call this function hyper names, in which we need to mention what is the ad stock transformation we are going to use. In our case, we are using geometric, but Robyn also supports another method called variable transformation based. Probably we can look at it in future sessions. And then the list of media, which is a union of both paid and organic media, essentially all the variables that require the both ad stock and saturation transformation. So let's look at the plot for the saturation here. So which has two hyperparameters. One is alpha and another one is gamma. So the alpha is going to control the shape of the response curve. So we could see that as the alpha increases, we have the response curve moving from C, which is more of a concave curve, to more of a S-shaped curve. But typically what we have seen was the C-shaped response curve is what typically we see. But sometimes if you see this kind of, let's say, some curves did not make sense, I think we should adjust the bounds. I'll come to that. And the second parameter is the gamma, which is going to tell us the point of inflection or point of the diminishing returns. And you could see that as the gamma increases, the inflection point goes farther and farther. For example, let's take this 0.1. We could see that only a few amount of exposure is required to reach a diminishing point, but as the gamma increases, we see this inflection point being really farther away. So it is really important to simulate or put our data through these transformations to understand the combination of alpha and gamma that explains the data. Okay, so now we need to specify these the hyperparameters for different media. For instance, for Facebook, in this example, I have the theta. Theta is nothing but the ad stock rate, the retention rate, to be specified between 0 and 0.6, right? So Facebook also gives us a recommendation for what could be the optimal, or the rule of thumb values for different media. For instance, for TV, it could range from 0.3 to 0.8. Unlike the digital media, so which could have the range from 0 to 0.3, right? Especially given the digital media advertising, we could have a shorter lag between the conversions and the advertising. So it 0 means it can have an instantaneous effect, and 0.3 means a 30% decay rate from 1 week to the another. And in TV, we could see that since it's offline media, people cannot take a decision purchase decision immediately, and there is a lag, as well as it has a higher retention rate compared to any kind of digital media. So these recommendations could be used to specify the ad stock parameters. And with regards to alpha and gamma, to account for the diminishing returns, it is recommended to try little wider values. So Facebook also gives us a recommendation for these two values between 0.5 and 3, and for gammas 0.3 to 1. So anyway, Facebook, finally, we are going to look at, let's say, if we tell to Robyn that give me the best models, let's say around 15 models out of maybe 1,000 models that we run, give me the best models that has the lowest root mean squared error, for instance. So it is also going to give us these parameter values and the response curves. So we can literally understand, okay, if some curves are really making sense or not, apart from just looking at the contribution percentages. And the another hyperparameter here is the train size, which is the fraction of observations we want to use to train the model. And we say that we want the training data size could be anywhere between 0.7 and 0.8. And the rest of the data would be used for the validation purposes. And once we have specified this list, the hyperparameters, we can feed this to Robyn inputs, add this parameters. Now, as a third step, we can go and build a model. So this function called Robyn run would take these inputs, apply the transformation, both Adstock and saturation, run the model. It is a simple, I mean, not a simple, it's a multiple linear regression model without any transformation on the response variable, like how Payman talked about the log linear model. And also it uses a ridge regression to kind of penalize for the coefficients having really larger values. So it also helps in mitigating the multicollinearity to some extent. And this next parameter is the number of iterations, which is it is going to build about 1,000 models, because remember, we are going to have models. There could be multiple combinations of these parameters, right? So I can have a model with theta 0.3, alpha 0.8, gamma to be 1. So there could be millions of combinations. So Robyn uses an algorithm called NeverGrad, which is a gradient-free optimization software that really smartly understands the region in which these optimal hyperparameters are there. So as the algorithm iterates from one iteration to next iteration, it is moving in the optimal direction. So I will show a plot which has this information in a minute. So once the models are run using this function, now the next question is, how do we select the model? There are about 1,000 models. How do we select the model? So even the model selection is automated by Facebook. It has this parameter called minimum candidates, which is nothing but how many number of models at least you need. So in this case, I'm saying at least I need 10 best models, but it can give me more than that. And it has this parameter called Pareto friend, which is nothing but out of these 1,000 solutions, it is going to identify the place where the best solutions are lying. For example, in this graph, you could see that each dot represents a particular iteration. And on the x-axis, I have the root mean squared error. On the y-axis, we have the decomp error, which is nothing but the distance between the spend proportion and the actual decomp contribution proportion. For example, I'm spending 10% on Facebook, and if the contribution is also 10%, then there is no error. So the best part is that it is accounting for both the prediction error as well as the error that is more aligned with the business expectations. So we could see that in the beginning, NeverGrad was finding solutions in this area where the error was pretty high. And as it converges in this area, we have this dark blue, which is around 1,000. I mean, in the region of let's say 900 to 1,000 iterations. It is really converges. We could literally see that. And this Pareto, it's another algorithm that is going to pick the best solutions that has the best trade-off between the root mean squared error and the decomp error. So even the model selection is automated using Robyn. And then the clusters, it has also a feature to cluster these solutions. Yeah.
Can I ask for one last thing? Where do I
Sure.
pick up the ad stock from? So show folks how
So the
do I
ad stock, yes.
train
I
the
think
ad
as
stock?
sure. So as soon as this function is called, then it is gonna dump all the results in the directory that we have given in the very beginning, right? For example, let's say I have specified that I at least need 10 best solutions. So it is gonna give me the summary of all those different solutions. Let's look at one of the solutions, right? And in this solution, apart from having contribution and the prediction plots, we also have the ROI information, and this is the ad stock information that we can get from here. Right?
Nice.
So staff has about 46.9% retention rate here.
Okay.
And also the response curves. Sometimes if you see that, let's say Facebook in this case, if client or us, we feel that this curve doesn't make sense, then we should discard the solution, even though it's probably having a good error rate sometimes. Yes, and also it gives us these CSV files which have this hyperparameter information as well. So where is that? Yeah, Pareto hyperparameters. So these are the solution IDs, right? For example, this is a solution. Its ID is 1883. So we just need to open this file and look for that particular solution ID, filter that, and we would get the corresponding hyperparameter values, the optimal values that it.
Got it. Okay, it trained on. Okay, got it. Okay, let's pause there for.